Let us solve the integral of cosine to the power 9x dx. So, when dealing with an odd exponent regarding sine or cosine in the integral, you must first transform this into its identity, which is sine squared of x plus cosine squared of x is equal to 1. But since we're dealing with here is a cosine of x, we must transpose sine squared x to the other side. So this would be cosine squared of x would be equal to 1 minus sine squared of x. So we must get a value of cosine squared of x in here and transform this into this one. So since what we have here is an odd exponent and what we need here is an even because this is 2, we must first factor out 1 cosine of x, so it will be even. So this would be the integral of cosine to the power 8x multiplied by cosine of x dx. And so what we need here is cosine squared of x. What we have here is cosine to the power 8. So we must just put it in the form that is cosine squared of x. So this would be the integral of cosine squared of x raised to the power of 8 divided by 2 would be equal to 4. Keep in mind that this and cosine to the power 8 has the same value. We just made it into another form. And copy the rest. And so now that we have a cosine squared of x, we must substitute this one. So this would be the integral of 1 minus sine squared of x raised to the power 4 multiplied by cosine x dx. Now the next step here, we can expand this expression first. But what I'm going to do here is to make a u substitution now for simplification. So let u here be sine of x. I will just substitute this into a simpler variable. And so the derivative of sine of x would be equal to cosine of x. Multiply this by dx. Now that we have our values, let us substitute it. So this would be the integral of 1 minus u squared, because this is sine squared of x, raised to the power 4. Cosine x dx is the same as du. So this would be simply du. And so the next step would be to expand this expression into its power of 4. So you can use FOIL method twice. Not FOIL method, but just multiply this by itself by 4. And so what you will have here is the integral of 1 minus 4u squared plus 6u to the power 4 minus 4u to the power of 6 plus u to the power of 8, and multiply this by du. And so we can now integrate this one by one. So first, the integral of 1 du. This is simply u. Since this is negative, put negative here. The integral of 4u squared du would be equal to 4u, 2 plus 1 would be 3, and divide this by its exponent, plus integral of 6u to the power 4 du would be equal to 6u to the power of 5 over 5, minus integral of 4u to the power of 6 would be equal to 4u to the power of 7 over 7. The integral of u to the power of 8 would be equal to u to the power of 9 over 9. And don't forget to add plus c, or the constant of integration. But keep in mind that is still not our final answer yet, because we must revert our variable into its original form. Our variable here is u, and its original form is sine of x. So, our final answer would be equal to u here is sine x minus 4 over 3, multiply this by u to the power of 3, which is sine cube of x plus 6 over 5 sine to the power of 5 of x minus 4 over 7 sine to the power of 7x plus 1 over 9 multiplied by sine to the power 9 of x plus the constant of integration. And so, the answer for the integral of cosine 9 to the power x would be this.